Good evening, everyone. Welcome to O-level physics sharing or lesson. Okay, my name is Mr. Chu. Today is the 29th of March, Tuesday. And we will be finishing up the revision on static electricity. Okay, before I start, I will want every one of you to ask me either one question about static electricity, or if you have no question, tell everybody one thing you know about static electricity. Any one thing. Okay, if you have a question, ask a question. If you have no question, tell everybody one thing you know. Okay, begin. Okay, Beiguan says static electricity does not flow. Not exactly correct, but also not exactly wrong. I'm talking about static electricity. Okay, share with everyone one thing you know or one question you would like to ask. Ryan, can you rename your name to your index number and your full name? Okay, Qiao Xing, can you share everyone? Static electricity exists only in insulators of electricity. Not exactly correct as well. Remember we learned about conductors. Ryan says that objects is negatively charged if there is more electrons than proton. Okay, Ryan, well done. Yu Ting says that insulators can only be electrostatically charged by friction. Okay, all right. Maybe you take away the word only, it'll be better. Okay, it may not be the only way. Okay, Yu Ting. Hey, why are you not sharing your info with everybody? Harry says that there are two methods of electrostatic charging, which are charging by friction and charging by induction. Okay, correct. You know the difference between these two? Xiaoxing says that static electricity exists only in insulators of electricity. Incorrect. Conductors of electricity also can have static electricity. Okay, I guess most of you have given me what you know. So let's begin with the first question. Okay, so can you all do part A? A is not about static electricity, but okay. A is about magnetism, which you haven't learned yet, but can you all please try? Explain why the magnet is attracted to the iron plate. Okay, can you all please try? Okay, this one, based on what you all learned before in lower sec and primary school, you all should know. Like, can you all please send me directly? Wei Kuan shared the answer, the unlike forces of the magnet. Okay, the word you don't use the word forces, okay, it's not the unlike forces. Okay, but good try. Wei Kuan. Wei Kuan, what's your topic that you learned so far? Okay, Yifan says that iron is a magnetic material. Correct. Okay, so the magnet is able to attract the iron plate. Okay, well done. Bei Kuan says that the unlike charges, okay, in this question, is a magnetic. Okay, why are they able to attract? It's because of the magnetic pole. So don't talk about charges. Yeah, so don't talk about charges. Okay, so Bei Kuan, so don't talk about forces. Okay, you are talking about the poles. Okay, Yufeng says that the iron is a magnetic material, so the magnet is able to attract the iron plate. Okay, well done. Okay, Bei Kuan is learning circuits right now. Xiaoxing says that iron plate is magnetic and will be attracted by the bar magnet. So the force of attraction between the magnet and the iron plate will cause the magnet to move outwards. Okay, well done. Okay, Xiaoxing, can you share your answer to everybody? Your answer so far is the nicest. Yuting says that iron is magnetic. Okay, don't say, okay, the iron is not magnetic, Yuting. The iron is a magnetic material. Okay, you do not know whether the iron is magnetic for now. Okay, but what you know is iron is a magnetic material. Okay, so it will be attracted by the bar magnet. So there's a force of attraction between the iron plate and the bar magnet, and therefore the magnet is actually attracted to the iron plate. Clear? Okay, so everybody, can you please look at Chelsea's answer? That is one of the best answers given by all of you here. Oscar says that the magnet is attracted to the iron plate as iron is a magnetic material and will be attracted by the magnet. Okay, Oscar, if you can write down there is a force of magnetic attraction. Okay, there is a force of magnetic attraction between the bar magnet and the iron plate. Okay, that will improve your answer further. Okay, let's do the next question. Okay, part B. Okay, explain why the foil is attracted to the earth iron plate. Why would this be attracted to the iron plate? Okay, you all may begin. Okay, if you all can do part B, then you all should be, you all will have understand this topic very well. Okay, part B is a very good question. If you understand how to do this, you'll be very good. Okay, I got the first answer by Bei Kuan. Bei Kwan, if I can give half mark, I will give you half mark out of 2. Okay, first of all, you must tell me why is there negative charge on the earth iron plate, and then why is there an attraction? Okay, you did not mention these 2 at all, so I do not know whether I can even give you 1 mark. Okay, so can you try to improve your answer, Bei Kwan? Okay, let me write down the answer for part A. Okay, for part A, this is how I will give the answer. Okay, beside Bei Kwan, how about the rest of you? Anybody need help? If you need help, type yes. Oh, sorry, type help. Okay, if you need help, type help. Okay, I'm waiting for the rest of you to do part B. Okay, where is everyone? Okay, wait. Let me read the answer by Oscar. Oscar, I will not give you any mark. Okay, first of all, the positive charge of the iron plate will not be attracted to the negatively charged earth. Okay, I do not know why you say the earth is negatively charged, so that is not correct. And then the iron plate is negatively charged, is true. Okay, it's true. And then you will be able to attract to the positively charged aluminum foil. That is also true, but not by magnetic attraction. Okay, that is false. Okay, so Oscar, I also do not know whether I can give you 1 mark. Are you clear about what you're writing? You need me to explain further? Okay, let me read Yufan's answer. Okay, Yufan says that the positively charges in the iron plate is being earthed. Why is the positively charged in the iron plate being earthed? Okay, that's why I don't understand. Okay, but the iron plate do become negatively charged. Okay, that's correct. And then since light charges attract, okay, why are there light charges attract? Okay, that's wrong. It's unlike charges attract. So Yufan, you may want to rewrite. Okay, let me read Qiao Xing's answer. Okay, Qiao Xing, your first sentence is correct. But you did not explain why it will move. You did not explain why the iron plate will become negatively charged. Okay, then your third sentence, unlike charges attract, is correct. Okay, your last sentence is correct. Okay, so for Chelsea, I'll give you 1 mark. Okay, the first 2 sentences, you understand where you go wrong? Okay, Oscar, you talk about unlike charges of the iron plate and the aluminum foil attract. Okay, that's correct. Okay, Chelsea asked me a question. Why does the iron plate become negatively charged? Yes, you must explain that, or you're not sure, you're asking me. Okay, that's the part you need to explain. Okay, the positive charges in the iron plate. Okay, Yifan, maybe your question, your answer. Yifan, your first sentence is still not correct. Okay, the rest of your sentence answer is okay. So I will give you 1 mark. Okay, you talk about positive charge in the iron plate is being earth. So that doesn't make sense to me. Okay, Chelsea, I'll explain to you in a while. Let me read Yu Ting's answer. Okay, Yu Ting, your answer is very long. Okay, I think your answer, I can give you 2 marks, but your answer can still be improved. Okay, those that I've explained, okay, never mind. Let's not confuse. Okay, let me explain to you using my way. Okay, so the iron plate is not charged at first. Okay, let me repeat myself. The iron plate is actually not charged at first. Okay, are you clear about this? Okay, the iron plate is actually neutral. Okay, it's not positive or negatively charged. Clear so far? However, when you put an aluminum foil near the iron plate, okay, there is excess of positive charges. Okay, so it will attract the negative charges and you'll repel the positive charges. Am I right or not? So the side that is nearer to the aluminum foil, let's say it's not earth. There's no earth. Okay, there's no earth. What happened is the iron plate a bit slightly to the left, we have a bit more electrons. Slightly to the right, there will be less electron. So what happened is because of this positively charged foil, some of the electrons on the right will be attracted to the left. Okay, clear? Does that make sense to you? But the whole thing is still neutral. The positive and the negative are still the same. Just that on the side that's nearer to the aluminum foil will be more negative. And this negative comes from where? It comes from the right side, and therefore the right side is more positive. Okay, up to this point, are you clear? Okay, if you are clear, give me a yes reaction. Why Ryan give me smiley face? Now you give me love face. Okay, Ryan, can you rename your Zoom name to your index number and your full name? Oscar is sleeping. How are you okay? Okay, now all of you know that positive and negative. Okay, these positive charges would induce the electron on the right to move slightly to the left because unlike charges attract, right? Okay, now we add in the earth. So what does the earth do? Okay, earth can provide 2 things, but not both. It's either one of the 2 things. Okay, if you have a shortfall of electron, it can provide unlimited amount of electron. If you have too much electron, you absorb the excess electron. Is that clear? Okay, so that is what Earth can do. Okay, so now there's no more Earth. Okay, sorry, now there's Earth. What happened is this? Because this aluminum foil is near the iron plate, this part of the iron plate will definitely have a bit more negative. Okay, because of this aluminum foil here. Okay, and then what the Earth here? Okay, but on the right side here, there is a shortfall of negative charges or a shortfall of electrons. Okay, so when you earth the iron plate, the part that is near the aluminum foil, nothing will happen. Okay, because it's already attracting, you'll still remain as negative. But the rest of the area, if it is not neutral, the earth will provide the electrons or absorb the electrons to make it neutral. Okay, so the left side will remain like this because of the positive aluminum foil. But the rest of the iron plate tends to be a bit more positive. So the Earth will supply the unlimited electron to make it neutral. Okay, so all these become neutral. Is that clear? Okay. And then here will still remains negative because it's near to this. Okay, so by earthing the iron plate, okay, the part that is near the aluminum foil will be negative. Okay, then the rest will be neutral. Okay, then what happens next? The next thing will be, because this part is negative, this part nothing happen. Negative and positive are unlike charges, they will attract. Okay, since they attract, the foil will move upwards. Okay, if you are clear about my explanation, give me a thumbs up. Chelsea, are you okay? You understand perfectly or you're still confused? So let me write down. You can also write down if you want. Okay, so free electrons from the Earth are attracted to the part of the iron plate nearest to the point. Okay, the other way you can explain is like this. Since it's already connected to the Earth, okay, it's already connected to Earth. Okay, let me explain another way. Hold on for a while. Okay, the other way to explain is since it's already connected to Earth, okay, the whole thing is neutral. Okay, there are proton, there's neutron, there's proton, there's neutron, there's proton, neutron, proton, neutron, proton, neutron, and so on. Okay, the whole iron plate is neutral. But once you move the aluminum foil close to the iron plate, instead of the negative moving from the right to the aluminum foil, there is an unlimited supply of electrons from the Earth, right? So some electron from the Earth will come from the Earth and to make the left side a bit more negative. Okay, that's what I'm trying to explain here. The free electrons from the Earth will be attracted to the left side of the iron plate, which is nearest to the foil. Okay, are you clear about this? Okay, then as unlike charges attract, the foil will move upwards to the plate. Okay, so this is the other explanation. So in your drawing, you don't go and put plus minus. Okay, what you do in your drawing is at first the whole thing is negative. Okay, because of the earthing, the Earth will provide the negative electrons, okay, to provide to the iron plate, and the part that's nearest to iron plate will have a bit more electrons because of the presence of the foil. Is that clear? Ken? So if you understand this explanation, give me a thumbs up. Is it hard to understand, or are you all very clear now? Okay. Auri, are you okay? Let me erase. Okay, now do part C. Two marks. Okay, so now you know that you attract, you move upwards. Okay, all the while it's not touching. But when it touch, after that you'll not be attracted and then you fall to the ground. Okay, so you move up until it touches and then you fall to the ground. You'll no longer attract. Why? Okay, can you all do that now? Okay, for part C, it's a 2-mark question. You all may begin. Okay, I got some answer coming in. Let me read. Bei Kwan. Okay, let me read your answer. Okay, Bei Kwan, don't use the word balance, use the word neutral. Okay, it's neutral or no longer charged. Okay. So Bei Kwan, if you can change the word to neutral, you'll be fine. Even your concept is correct, but this is a 2-mark question. I will not give you 2 marks, but your concept is correct. You need to explain how the foil become neutralized and why the foil will neutralize upon touching. Okay, so that's the thing that you are lacking. Let me read Yiting's answer. Yiting, the friction between the foil and the iron plate is not part of this explanation. But the rest of your answer makes sense. Okay, but there's no friction at all. Basically, there's a transfer of electron and so on. Okay, you think you clear? Okay, Qiao Xing. Qiao Xing, you must explain how it neutralizes, how the electrons neutralize the foil, then they'll be okay. Okay, Qiao Xing, other than that, your answer is fine. Okay, Hao Rui. Okay, Hao Rui, your answer is actually quite short and simple. I will have give you the full 2 marks if you tell me that the foil becomes neutral. Okay, that's the thing that you lack. Other than that, the rest of your answer is perfect. Yiting asked me, how does the transfer? Or just by touching, once you touch, electron can flow, because both the aluminum and the iron are metal. So electron can flow easily. Okay, you don't need friction for it to flow. But for insulator, you need friction. Okay, but because both are metals, it's very easy to flow. Okay, you got it, Yiting? Okay, Bei Kwan, your answer. Okay, Bei Kwan answer is not perfect. Well done. I'll give you 2 marks. Okay, Chelsea, you got it correct. Very good, very good. Okay, let me share with you how can you also give the answer. Let me give you my answer. So there is a transfer of electrons from the iron plate to the foil when they touch. Okay, when they touch. You all know why does it transfer? Because the earth itself is neutral. Okay, so the earth will always try to neutralize whatever they're touching. Clear so far? Okay, so there'll be a transfer electron from the iron plate to the foil when they touch. Okay, so as such, the charge on the foil is neutralized. Okay, as is the iron plate. So both the foil and the iron plate will now be both neutralized because there's no induction of electrons. Okay, so when they touch each other, it's like one big conductor. The whole thing will be neutralized because of Earth. Okay, why is the iron plate have a bit of negative charge? And even though it's connected to Earth, it's because this positive charge will always make the left side of this iron plate slightly negative. So therefore, the whole thing is negative slightly on the left side. Okay, but when it touch, electron can jump to the aluminum foil, and then the whole thing is like one big conductor, and then the whole thing will be neutralized. Clear? So both the iron plate and the foil will be neutralized. So since both are neutral, the foil is no longer attracted to the plate. Understand? Okay, if you understand this explanation, give me a thumbs up, everyone. Okay, if you are not clear, ask me in the chat. Okay, how Ray, Yufan, are you okay? Ryan and Yuting, can you remove your tick? Remove your tick. Okay, thank you. Okay, so after doing this question, I hope that you are very good at static electricity by now. You understand the concept because this question actually tests your concept very well. Okay, are you okay with this question so far? Do you feel that you understand this topic very well now? Okay, let's do the next question. 2016. All right. Okay, who can tell, who would like to draw this? Draw the electric field. Okay, can I have one person want to draw? Okay, raise your hand. Then the rest of you do part 2. The person that draw don't need to do part 2. Okay, the one person who want to help me draw part 1, please raise your hand. Nobody. No, like that. Okay, Ryan, you remove your yes reaction for now, Ken. Okay, I have one volunteer to do part 1. Just draw the electric field. Very simple, this one. Then the rest of you will do part 2. Can you please do now? Anybody? Okay, Chelsea, you can do part 1. The rest of you do part 2. Okay, Yuting, I'll give you 1 mark. Well done. Okay, Ethan, yours for part 2, the question is asking you, what does the direction of the electric field show you? Okay, can you see? Chelsea draw the line, the arrow here. Okay, Chelsea, well done, you got it correct. So you see there's arrow pointing down towards this sphere. So what does this line and the arrow means? Okay, Ethan, can you explain that? Okay, so your answer you need to rewrite. How well done. Quite incorrect. Okay, so I need you to explain what does this one line with the arrow means. Okay, why are we pointing one line towards the sphere? What does it mean? So can you please try? Okay, Pei Kwan, try again. Yifan, yes, the electric field is moving into the negative charge sphere. So you're supposed to explain what does that mean. Okay, what does that mean? What does moving into the sphere means? Incorrect, nothing to do with neutralization. If let me give you another clue. So for example, I got one positive and one negative charge here. Okay, the field line is like this. So what does this line actually show? Why is there the path with an arrow? What does this path tells you? Okay, this path with the arrow is a path for what? Okay, Yifan, try again. Okay, this line, this path with an arrow is a path for what? What thing will be moving in that path, in that direction? Okay, that is the answer for this. What is the thing that's going to move in that path, in that direction? Incorrect, Yifan. You look at your notes or textbook, what is an electric field? Okay, you go and read the definition of an electric field, you will know your answer. Okay, so Yifan, let me ask you, you tell me electron. Can you see the sphere here is negative? Will an electron be attracted to a negative sphere? Oscar, incorrect, huh? 北宽, I will give you the mark, but it's not totally correct. Okay, it's not totally correct because you talk about towards the negative sphere. Okay, your answer is okay, but it can be written better. Yeah, Yifan. So what does this field line means? This arrow, this orange arrow that Qiaoxing draw is a field line. Okay, it's an electric field line. So what does it mean? What thing will actually move in this path in this direction? Likewise, what thing do I put here will allow it to move in this path in this direction? What thing? If I put a mass of pencil case or a mass of a metal ball, will it actually move in this direction? Yes, that's the definition of the electric field. Okay, so what is the electric charge? Okay, okay, so let me share with you the answer. Basically, the answer for this, okay, this one is to remember. It's not really about understanding. It's not about the concept. But this thing that you remember is the same for electric field and magnetic field and gravitational field. Is that clear? They are all the same, just that one is mass, one is charge, electric charge, and one is a magnetic pole. Okay, so what does this arrow means? Okay, let me explain to you. It is the direction of, the direction of the electric field, okay, actually shows the direction of movement. Okay, it's actually the movement of a positive charge. Okay, so Oscar talk about, okay, Oscar did not talk about positive charge. Bei Kwan says proton. Okay, don't use the word proton. It's a better word. It's a positive charge. It's the direction of the movement of a positive charge placed at that point. Is that clear? What do I mean? If I were to put one positive charge here, okay, it will move in this path in this direction. Are you clear about that? Or if I were to put a positive charge here, it will move in this path in this direction. Okay, if I put a positive charge here, okay, can you see? Positive will repel, positive and negative will attract, If I put a positive charge here, it will move in this path, in this direction. Are you all clear? Okay, so for Oscar, don't need to write the negatively charged sphere. The question is asking you, what does the electric field means? Okay, don't need to talk about moving from where to where. You just need to tell the teacher, it is the direction of the movement. Okay, so this orange line is the movement, but it's moving from up to down. Okay, for this orange line, the positive charge will move along this line from right to left. Oscar, is that clear? So you need to just write down the direction of the electric field shows the direction of the movement of a positive charge when you place it there. Okay, are you clear about the explanation? Okay, if you are crystal clear, give me thumbs up. Maybe if you are still confused, type it out in the chat. So I will actually explain to you further. Okay, Ryan, you raise hand, right? You got a question for me? Okay, so you put no reaction means you need me to explain more. Okay, so the rest of you, do you understand now? Okay, am I helping you able to crystallize the concept to you better? I hope so. Okay, let's look at part B. Part B on part 1 is 1 mark, part 2 is 1 mark. Okay, so for part 1, I need a volunteer except for Chelsea. Then the rest of you do part 2 and type it out to me. Part 1 very simple, right? Okay, so I just need one person to volunteer to do part 1. The rest of you do part 2. So I need volunteer. Okay, raise your hand. Okay, very simple. I just put positive, negative only. Nobody want to try. Okay, Bei Kwan, you may do part 1. The rest of you do part 2. Bei Kwan, there's two lines there. Or you're still writing. Okay, the rest of you do part 2. Why is the force on the bottom larger than the top? Bei Kwan, are you still there? Okay. You want to do again or you want to leave the answer like this? Okay, Chelsea, correct. Yeah. Even your part 1 is correct. Do part 2. Okay, let me explain part 1 first. Okay, Bei Kwan, your answer is incorrect. So can you see this part and the bottom part, this area, can you see that it's actually moving closer to the sphere? So there is some attraction here. So my question is, does light charges attract or unlike charges attract? Okay, I repeat again. Light charges attract or unlike charges attract. Okay, attraction is actually unlike, right? Okay, so the charge here and the charge here should be unlike. Okay, so the bottom charge is positive. Understand, Pei Kwan? Okay, originally the metal strip is like this, right? Can you see the metal strip is like this? So the metal strip actually moved to the right. Therefore, it becomes curved. So there's an attraction to the sphere. So why do they attract? Because of unlike charges. Okay, Pei Kwan, if you are clear, give me a yes reaction. Okay, then, therefore, the other side will be negative. Okay, why is it negative? Because the top here is plastic rod. So the plastic rod is plastic, it will not provide or absorb electron. So the whole metal strip should be neutral. Okay, the net charge should be 0. Okay, there will be no extra charges. So where does the extra positive charge come from? It will come from the top. So what should happen is the electron actually move to the top. So therefore on top become more negatively charged, and therefore the answer on top is negative. Okay, where are the rest of you? Only Qiao Xing gave me the answer for part 2. So quickly give me your answer for part 2. The rest of you give me answer for part 2. Hurry up. If you are not sure, give me just tell me help. Type help in the chat. Okay, I'll wait for the rest of you. It's just a 1 mark question. Can you hurry up? Okay, part 2. It's just 1 mark. Just 1 mark. Okay, Yiting, well done. Hello, why am I waiting so long for your 1 mark answer? Even incorrect, incorrect. Okay, why? Where are the rest? Oscar, Ryan, and Harry, where are your answers? I'm waiting. Okay, I'll not wait anymore. I'll just tell your mommy you're not participating. Should I do that? Hurry up, Leh. Oscar, Harry, Ryan, what's your answer for part 2? Okay, you found incorrect, huh? Let me give you a clue. What's the difference between the distant 1 and distant 2? Okay, that's a clue, huh? Okay. Ryan, Harry, Oscar, are you there? Ethan, please on your camera. Where are everyone? Where is everyone? Okay, let me share the answer with you all. So I talk about D1 and D2, right? Okay, let me share the answer with you all. The magnetic strength, so sorry, not magnetic, the electric the strength of the electric force is dependent on the distance between dependent on the distance. Okay, so as the bottom of the strip is nearer to the sphere, okay, means that D2 is less than D1, correct? The electric force is greater. Understand? Okay, the question say larger, right? So use the word larger instead. Follow the wording in the question. Okay, how will give me the answer? Huh? Okay, how Ray, the way you phrase very funny because you say longer distance, then the force is larger, and therefore larger resultant force. Do you see the contradictory thing that you mentioned? Okay, so it's not correct. It's longer distance, therefore smaller force, and therefore smaller. Is that clear? Okay, so Ryan, well done. Okay, let's go to the next question. Okay, so if you are clear about this question, which I think is quite badly done, I hope you learned something today. Give me a yes reaction. Okay, if you understand this question now, give me a yes reaction. Only one person give me yes reaction. Okay, are you clear about this? Oscar, where are you? Haven't given me your answer yet. Okay, the next question, let me go through. Okay, let's look at these 3 questions or 4 questions. Okay, y'all may begin. Okay, y'all start doing, and I want y'all to type in A, B, C, D. Okay, answer for A, answer for B, answer for C, answer for D. And then, can you see that the question here, they are all just 1 mark. So please don't take too long to do this question. Okay, don't take too long to do this question. They are just 1 mark each. Okay, so when you give me your answer, you type down A, your answer, B, your answer, and so on. Okay, you all may begin. Okay, quickly do. Just type down A, answer what, B, answer what, and so on. Okay, Chelsea, your A is incorrect. Okay, Chelsea, let me highlight the clue to you. Okay, which is the first sentence here. Oscar, just one word will not give you the mark. Earlier on, you went missing, then now you come back, just one word. You need to explain. They give you two lines, now give me two words. Hello. These four questions are 1 mark each. So far, only Chelsea has given me part A answer. The rest of you are not giving me anything yet. Pei Kwan, I will not give you the mark. But your concept is almost there. It's almost there. Okay, wow. Ethan, give me everything in one shot. Okay, Ethan, your part A is correct. Ethan, your part B, I will give you the 1 mark, but it can be done better. Okay, you find your part C. Remember I told you all before, the positive charge will not move. Okay, in a conductor, in a metal, positive charge will not move. It's the negative charge that move. Okay, so you think again, how the negative charge move? It move to the earth or you come from the earth? Okay, you find your part D is correct. Okay, even though you write one word. Okay, Yu Ting. Part A correct, Yu Ting. Yu Ting, your B, I'll give you 1 mark, but it can be explained better. Yu Ting, your C, I'll give you 1 mark. Okay, Yu Ting, for part D, why would transporting flammable liquid is an example of electrostatic charging? Okay, when you transport the flammable liquid, right? Is there any electrostatic charging taking place? Okay, so your part D, can you think about it again? Okay, Howry, your A is correct. Howry, your B is correct. Well done. Ryan, your C is correct. Okay, your D, very interesting answer. Well done. Okay, for D, what Howry say is, okay, Howry say the dust and dirt attracted to the phone screen or your computer laptop or your iPad or your tablet. Yes, that is one example when it is a nuisance, but it is not a hazard. So I don't know whether she'll give you the mark. But the idea is correct. Well done, Howry. Okay, Chelsea, your B, I'll give you 1 mark, but there's a better way to explain. Okay, Chelsea, your C and D is correct. Very good. Okay, you think your D is correct. Very good. Oscar, your Oscar, your answer is for part A or part B? Okay, I'm confused. Okay, I'll give you the mark for part A, but it can be improved. Okay, let me share with you the answer for A, B, C, and D. Okay, so as the fuel passes through the hose, it will rub against the hose, correct? So when you rub against the hose, there's some friction. The fuel will lose electrons to the hose, and therefore the fuel become positively charged. Okay, are you clear about this? Okay, next. Why would this positive charge cause the fuel to ignite? Okay, most of you did not say the first thing is, which is when there is a sudden discharge of the excess charge. Okay, so it's positively charged. So when the positively charged, suddenly there's a sudden discharge, meaning a lot of electron comes in. Okay, so when the electrons are moving, there is an electric current. Okay, so a sudden discharge of excess charge will have a current, and because the okay, and therefore when there's a sudden discharge, there is a current. It will actually cause a spark, and therefore it might ignite the fuel. Is that clear? So why would there be a sudden discharge of excess charge? So for example, if I bring a metal pole near and touch the fuel, okay, what happens? Because the fuel is positively charged, and then the metal has some electron, there will be a sudden discharge. A lot of electrons will actually just jump to the fuel. Okay, so this discharge of excess charge will cause a spark. And once there is a spark, it might ignite the fuel, it might just burn. Are you clear about it? So how would there be a sudden discharge of excess charge? Is, for example, you place an electrical conductor like a metal. Okay, for example, in this case, metal. Okay, so when I place a metal near the fuel or aircraft, okay, a spark, okay, there will be a sudden discharge of excess charges, and a spark will occur. Okay, a spark might occur. Okay, so when there's a spark, what happens is it might ignite the fuel. Are you clear about that? So I repeat again. So if you touch or you bring an electrical conductor near the fuel, because the metal has free electrons, am I right? But the fuel is positively charged. There's a lot of excess positive charge, meaning there's a lack of electrons. So when you touch the metal with the fuel, because of the difference in charges, a current may flow. So this discharge of excess charge causes a current. Okay, it causes a current. Okay, then that sudden movement of a current will produce a spark, or may produce a spark, and that spark will ignite the fuel. Is that clear? Okay, now part C. Why would I put a wire to the ground? Okay, so in this case, the ground will act as a earth. Are you clear about this? Okay, the wire, okay, the ground acts as earth. Okay, so the wire from the ground, in this case, allows electrons from the ground to move upwards to the aircraft. Okay, so the ground acts as your earth. Okay, it supplies electrons. And that will neutralize the excess positive charges on the aircraft. So your aircraft will no longer be very positively charged, and then all these sudden discharge will not occur, and therefore the danger is reduced. Okay, for part D, okay, besides refueling, the other thing that will happen is lightning. Okay, let me explain to you. I will not type it out. Okay, so I want you to hear carefully. Okay, how does lightning occur? Okay, during electrostatic charging. Why would there be electrostatic charging? Okay, so for lightning, because there's movement of the air and the cloud. Okay, so excess charges can be built up in the cloud during a storm. Then suddenly, there is a sudden discharge to the ground. So the excess charges move from the cloud to the ground. So there's a path. That path itself is your lightning. Okay, and that lightning can hit a person or a building, causing death, injury, or damage. Okay, so if you are clear about all these explanation, give me a yes reaction, please. Thank you. Okay, next week we will start the new topic. So I'll go through one last question. Actually, I got two questions. Yeah, just go through one last question. I think by now, I hope you all know this topic very well. Okay. Before I continue, out of a rating of 10, 10 means you know static electricity very, very well. And 0 means you know nothing. Can you tell me how much you know about this topic now? Hey, why you all 7? What happened to the other 3? Hey, y'all give me 6 to 7. What happened to the other 3? The other 3 point go where? After 3 to 4 lessons of this, why is there still not perfect yet? Yeah, where's the remaining 3? Okay, go to the last question. Okay, let's do this. Look at question or do part A, 1 and 2. Okay, 1 is 4 marks, 2 is 3 marks. So these 2 questions cost 7 marks. Just not the 4 marks you take so long. Okay, these 7 marks shouldn't take long as well. The longer you take, the later we end. So continue. Okay, Ethan, I will give you 3 marks for it. In the end, your metal plate will not be positive charge. Okay, your metal plate is not positive charge. Your first 3 step is, wait, hold on. Okay, sorry, Ethan, I will give you 2 marks out of 4. Your first 2 steps is correct. Okay, up to the earth part. Then the third step you did not mention. The fourth step, your charge is wrong. Okay, Chelsea, I'll give you 4 marks. Well done. But can you say move the metal plate away? Okay, away from what? From the rod. Okay, can you just be a bit more specific? Okay, Chelsea, you get 4 marks. Well done. Do part 2 now. Ethan, you're correct. Positive charge is not movable, but you must remember, Earth can either provide electrons or it can absorb electrons. Okay, the Earth itself can provide, supply electrons, or it can actually absorb electrons. So in this case, what happened? Okay, who else? I got 2 answers so far. I'm quite happy because you all know what's happening. I'll give you the first step. Okay, Pegon, why you write the same answer as me? Okay, what's step 2? Okay, when we bring the positive charge close to but not touching the metal plate, okay, what actually happens is when you bring close, on the left it will become negatively charged, on the right it will become positively charged. So what happens is that the negative electron will move to the left side. Is that clear? That is your first step. Then what's your second step? Can the rest of you continue? Okay, so with the rod still close to the plate, okay, connect the lead to the opposite end of the metal plate. Okay, that's part 2. Let me read the answer for Ethan. Okay, Ethan, you cannot remove the positive charge. It's either you supply electron or you absorb electron. The positive charge cannot move. So yes, you are supposed to remove the positive charge by doing what? By adding electrons or removing electrons. And that's what the Earth is for. Okay, Ethan, are you clear? Okay, so Ethan, you get it correct, but the positive charge, that part you need to explain clearer. Okay, so for part 1, you're just supposed to write the step. And part 2, you're supposed to explain what happened. Okay, let me read Chelsea's answer for part 2. Okay, Chelsea, I'll give you 3 marks, but your answer can be better for part 2. Okay, Haori, I'll give you full marks for part 1, but you actually combine 1 and 2 together. So for part 1, okay, Haori, just write down the step, then explanation put in part 2. Is that clear? Okay, Oscar, your answer is perfect. So Oscar, can you please share your answer to everybody? Okay, part 1 is very simple. Your answer is very simple. Just the step. Okay, explanation do part 2. Okay, Yufeng, yes, your Earth provide electron, correct. That's how you actually neutralize the positive charge. Okay, Qiaoxing, I'll give you the right mark for part 2, but can you just add on a bit of things like when the lead when the metal plate is connected to Earth, what happened? Can you say something like that? When the metal plate is connected to Earth. Okay, Yuting, can you share your answer to everybody as well for part 1? That is perfect. And so part 2 as well. Okay, Pei Huan, your part 1 is correct, but your step 3 can break it down into 2 steps or not. Remember that the question is 4 marks. If you write 3 steps, you know something is not very correct. Okay, so break down your step 3 into two steps. Okay, so I want everybody to see Oscar's part 1 as well as Yuting's part 1 and 2. Okay, Oscar, your part 2 a bit funny. Okay, let me share with you the answer for part 3 first. Okay, so number 2, connect the lead to the opposite end. Number 3, disconnect the lead to the plate. And then number 4, okay, remove the rod. Okay, remove the rod. Okay, remove the rod away. Okay, then therefore the metal plate is now negatively charged. Okay, that's the 4 step we need to do. Okay, part 2. Part 2, state and explain what happened to the charge on the metal plate during the charging process. Okay, so what happened? Okay, I will not type it out. So I want you to listen to what I say. Okay, so follow me. So when I put the positively charged rod near the metal plate, okay, the electrons in the metal plate will be attracted to the positively charged rod. And that is because unlike charges attract. Okay, so this leave behind a positive charge on the opposite end of the metal plate. Okay, now here that you see. Then when we connect the lead to the metal plate, electrons from the Earth will be supplied by the Earth to the plate. Okay, and attracted to the positive charge. Okay, because unlike charges attract. Is that clear? Okay, so the electrons from the Earth will be attracted to the positive charge of the plate because unlike charges attract. Okay, and that will cause the positive charge to be neutralized. So now, after you remove the lead, only the negative charge remain. Okay, there's only now an excess of negative charge in the plate. Then, when you remove the positive charge rod, when you remove this away, the electrons will rearrange throughout the metal plate evenly. Okay, and that will result in a negatively charged metal plate. Are you clear about this? If you are super clear, give me a yes reaction. If you are still confused, give me a no reaction. How are you okay? There's still another part to this question. My last question for you is, you want to do the last part? Let me show you. Or you want to go and rest? Okay, so can you type in the chat, do or rest? This one. You want to do or rest? Type it out. Do or rest? Okay, do you want to do or rest? Do or end? Please let me know. Okay, Bei Guan want to do. Okay, let's do this question. Okay, everybody do now. The rest of you, nobody give me a response. Okay, all of you do this question now. So this is an example of a laser printer. Quite interesting. Okay, all of you do this question now. This should be the last question for today, and then we'll end the class. Okay, there's something that is you all did not learn in school. Okay, this part you all did not learn in school, but it's given to you as a fact here. So you need to know, you need to use this fact to answer part 1. Okay, so the area where the drum become conducting. Conducting means it can conduct electricity or charges. So what happened? What happened to the charge on the drum where the area where there's light? Refer incorrect. So initially the drum is an insulator. Can you see here? At first, the drum is an insulator and it's positive. Then when you shine light onto that part of the drum, that part of the drum become a conductor. So what happened to the charge on that part of the drum? Okay, what happened to the charges on the part of the drum? There's only 3 possibilities. It remain positively charged, it become negatively charged, or it become neutralized and become neutral. So which one do you think is the correct answer? Okay, the key word here is when insulating become conducting. What's the difference? It means that the conducting part, there will be free electrons. So what does that mean? The electron can freely move. Okay, so at first it is positively charged, means that there's lack of electrons. Then it become conducting. Suddenly the electrons there can move. So what happened? Anybody need help? Type help. Referred incorrect. Incorrect again. Sorry, no, not incorrect. Yeah, that's the original answer you gave me. Okay, then the other thing I want to say is this is the surface of the drum. Okay, the surface of the drum. Okay, so the surface of the drum is insulating and then it's positively charged. Then inside the drum is made of metal. Okay, so when you shine light, okay, when you shine light, the part where it is insulating become conducting. So what happened to that region? What happened to the charge? At first, it's positively charged, a lot of positively light of electron. Then, when you shine light, it becomes conducting. So what happened to the area? Electron can move there already, right? So what happened? The area become neutralized. Are you all with me? Are you all with me? Okay, so the question here is, what happened to the charge on the drum in the area? You write down the positive charge on the drum is neutralized. Okay, when the light strikes. Clear? Okay, so the thing is, must say is, it becomes neutralized. Now do part 2, question 1 and 2. That's the last 2 part of today. Okay, so this toner here, this toner, okay, this toner here, this question is talking about this toner. Okay, this toner does not stick when the drum is positively charged. Okay, so it will not stick. So this is the ink. The toner will not stick. Okay, the toner does not stick when the drum is positively charged. So the area where there's no light will still be positively charged. Then the toner will not stick, so there'll be no ink. But the part where there is light, the region will be neutral. So when it's neutral, it will stick. Is that clear? The print will be black. So suggest why the toner does not stick. Okay, Qiao Xing, well done. Qiao Xing said the toner is positively charged. Okay, Yu Fen, well done. Yu Fen says that the toner is positively charged, and then since light charges repel, it will not stick. Very good. Okay, so basically you get the idea. I'll just write down the answer for 1. The answer for 2 will be the opposite, but you can explain in detail. Okay, so you must explain that the toner is positively charged. Okay, so thus it is repelled by the positively charged drum or the region as light charges repel. Okay, are you all with me? Are you all clear? Beikwan, nothing to do with unlight charges attract. It's because they are light charges, therefore they repel. Why do you write there unlight charges attract? Okay, the explanation will be wrong. From correct, your answer become wrong. Okay, let me explain to you why the toner will stick to the conducting region. Let me explain to you. Okay, because the toner itself is positively charged and the conducting region is conductor, right? So the conducting region are neutral. So the positively charged toner powder will be attracted to the electrons in the conducting region. Okay, as unlike charges attract. So this causes the surface of the conducting region to become Negatively charged, causing the toner to stick to the conducting region. Is that clear? Okay, if you understand question number 2, part 2, give me a thumbs up. Give me a thumbs up. Are you perfectly clear? Did your understanding of this topic become better? Does it increase from 7 to 8 or 9? Okay, next week you'll be going through the electric current already. Okay, so any question for me? Okay, if there's no question for me, okay, I got no question for you. You may leave anytime you want. So if you have any question, you can stay back. Okay, thank you so much. Have a very wonderful evening. Good night.